You should see the beautiful slide.
Yes. Yeah.
All right. Okay. Um, all right. So let's get started. So for those who went here at the start, I am Max. So I am one of the co-creator of the Grid protocol, which is a protocol which we're trying to build around IAM, but not just IAM. So not just for chat and instant communication, for other things, but that's the main goal of what we're trying to do. I will explain quickly so who we are and where we come from and how we ended up creating this. In short few lines, and then I will focus on why Grid and what makes it different and what are the core values that we're trying to go for compared to any other protocol or platform that you use so far. So about us. So we started some years ago as a company which is called Camax, and our goal was to provide tools, services, and software to people or companies in as like free software or privacy oriented solutions. So we really care about those two things. This is not just about a business per se, it's also about the social mission behind and trying to actually make IT better for people overall and empower the people, whoever that they are, individuals or people working in companies. Because we believe also that companies themselves or organizations, especially the smaller ones, should be given chance and power to control their data or control what they do and of their clients as well. So we started a few years with that, and we were always looking for mainly an IAM platform. So we could find tools like Nextcloud, which gave solution to like file sharing or those, but we never could find something that we really liked and really trusted as a solution, either for people or for companies, in terms of instant messaging, anything around it. So we kept digging for several years. We came across several things. So we try obviously XMPP or all those things, but they aren't up to the standard we wanted. And we'll go into details after about those standards. Um, we tried also what is called Matrix, and that's what Grid is based on. But we were not happy. It's close enough in terms of some of the features, but it's not there yet. So what we decided to do is to basically also create a non-profit for Grid to back up all the work that we're about to do that does not fit as a for-profit company, because creating a protocol, for example, doesn't bring money on its own, or it doesn't you can't really sell a protocol, and it's not the point of a protocol. You want to make a protocol open and have everybody. So we created a non-profit in Luxembourg, which is called Libre Monde. And that's what all the work that we're doing in terms of protocol is based on. And that's where everything for Grid is done. And the implementation themselves, we do them under our for-profit. So we differentiate these two important things. That's pretty much who we are. So this is me and Cathy, who's the other co-founder of those two organizations. And I'm basically the technical lead. I'm the person who does all the technical things. And Cathy is the person who does all the non-technical things, so communications, graphical things. She's the one who designed, logos and pictures and all these things. So there you go. That's a bit who we are, where we come from, and how we ended up working on this. So I'm just making sure our thing is aligned. Okay. So about Grid itself. So we have the important core values that we always wanted to have in any protocol we looked at. First of all, was that it's open source and open standard. So we want a protocol that is not proprietary. We don't want that the basic tools which are created are proprietary. We actually want to make sure that the users and the people who care about these things are empowered. So we give them control about what they do and how they do it. And for us, that's the most important. We're not here to build a protocol to sell it afterwards or anything like that. Obviously, we are interested into services and things like that, and make a living like everybody. But we're not here to. It's not a startup, and we're not here to build something very nice and then 2 years later just sell it to the highest bidder and just leave all the user in the dust and things like that. So that's not what we in for. We want it decentralized, so that's very important. So we don't want to create any centralization in what we do. That was one of the things that is a problem, for example, in Matrix and what we see on the day-to-day. So either it's not directly made as centralized, it turns out that it is in a way, and we want to definitely avoid that. And when I say decentralization, it's both in terms of data. So the data is replicated or not, depending on how you want to do it, across several servers or clients, but also in the way things communicate. So in the sense, decentralized is very much like email works. So everybody can spin their own server, and then they can just email each other, and it's the same here. You can just send message to each other, and everybody has a copy of what you sent, whoever the recipients are. They each have a copy, and everybody can spin up the server or the client, and there's no central point of control in any way. So that was the second value, very important to us. The third one, if not the most important, is privacy related. So we really want privacy friendly tools. I'll go into a bit more details about this after in terms of what it means. But the highlight is that because we're based in Europe and we're very interested into obviously the laws and everything, there's GDPR. And we definitely want to build this protocol which is ready for GDPR. That's the most important. I know in some states, isn't it California, you also have laws which come close to GDPR in the US. But obviously, overall, anything which is made in the US so far that we've seen does not come close to what's required in terms of law for GDPR and things like that. So we need that. We want to be able to say, well, look, GDPR is in place, it exists, it's there, it's out there. You have to take into account, and the protocol or the tools should take that into account. And most important is that whatever we create should be user friendly. So we've seen many times the tools were created for technical people, or at least were very hard to use for non-technical people. And that makes it very easy. So we saw it with our friends, our families, with the clients that we work for, just people in general. Anybody who's not technical has a very hard time using, things which are non-proprietary at the moment. So XMPP, IRC, Matrix, whatever you can think of. It's never really easy, and that's why everybody tends to fall back on WhatsApp or Facebook Messenger or Telegram or whatever. They are made user friendly, and that matters a lot. So we should take that into account. So now I'll go into more the details, the technical details of things, or the specifics. Has anybody has questions so far that didn't know about Grid before? Or should I continue?
Good so far.
Okay. Just so don't be afraid to interrupt me. in any case, so if you have any questions. So what do we mean by decentralized? So how are we gonna achieve that? We're gonna use a set of easy technologies and things that always come in libraries and are always around. So HTTP, so everything is HTTP based at the minimum set of compatibility. So HTTP in terms of protocol, but everything's gonna be HTTPS by default. So everything is encrypted. Again, this goes back to privacy. We shouldn't allow any communication which is not HTTPS. In terms of message themselves, we're gonna use JSON simply because it's one of the most used format. We don't want to use XML or something crazy like that. It's way too difficult to read or write overall, and libraries are hard to use. So that's what we didn't want. So DAG based. So I don't know if anybody. There's a question. Wait, because is it turnkey and infrastructure like email? Yes, Fong. So that's definitely how I want it to be. So there's the protocol itself, which we're designing through the nonprofit, and there is the implementation themselves, which we write under our own for-profit. What we want to do is differentiate these two activities, and what we want to say in the protocol specification, or let's say the message that we want to send out, is that this should be super easy to run. It should be at least as easy as email, and it should be very, very simple in terms of how you implement it and how you do it. So what we really want, yes, we really want a turnkey solution, or at least a protocol which allow turnkey solutions, or that allow developers to write these implementation very, very easily. And you're right, ISC. So ISC was one of the reasons that that wasn't even possible in the first place to build on or start from, is because there's no notion of federation per se. It's not federated in any way. It's, you have clusters of servers that deliver to a single network, but you do not have federation. And federation is one of the things that we want to do. So that's literally the next step I will talk about. Does that answer your question, Fong? Did I answer it? Hopefully, yes. Just let me know if not.
Yeah, he's got his mic turned off.
Yeah. So there you go. So that's the four point. So I will get into federated in more details. So one thing that we're gonna base the protocol on, which will allow many things, is the notion that is DAG based. So DAG is direct acyclic graph. It's a very, very complicated word to say that basically each message can have a pointer to previous messages. That's what it means. So it basically, like emails, when you receive emails and you have threads, and basically your client is able to display the order in which the emails were sent and have it relate to each other. It's basically because in the email you have a property, which I don't remember the name, but you have a header that gives the ID of the message that happened before. And so you're actually able to say, well, this happened before or this happened after, and have it relate to each other. That's one of the things that we're gonna add to the messages, have it sent out, and it's gonna be optional. So some messages can contain it because you actually want to have the ability to go back and fetch history and resolve this, or maybe you don't want because you want message which are more private, and you actually don't want them to to be found by anybody else. So they will be the choice. And when I'll show the more in how it works, when I'll run it, I'll show you what it represents in terms of actual message at the JSON level, so you can see. And so federated for us is very important. So federated is it's just like email. So it's the idea that everybody can have their own domain or their own server, their own namespace if you want. It doesn't have to be DNS based. Everybody can have their own namespace, and they can run their server or the client, which can be this can be peer-to-peer as well, and they can just receive their message. So they do not depend on anybody else. Thank you for this very pretty drawing. Whatever that was. Oh my God, you can't remove it now.
Sorry.
Was it you, Des?
That was definitely not me.
This is ruining the whole presentation. I do not agree with this. I don't know how you get rid of it.
I'd say go on to the next slide.
I did. This is already the next slide. That's it.
Yeah.
There you go. Okay.
Well, we don't know who's responsible. It's like Harold and the Purple Crayon.
Okay, so privacy friendly. So privacy is complicated. Privacy is very complicated because it involves things like, see, people keep drawing. It's very complicated because it involves various laws. So, for example, in Europe, so we have GDPR, and GDPR came into force in 2018, and it's a total shift in terms of how privacy is handled. So before, it was a privilege if you could access your data. It was a privilege if you could know what the hell was going on and how it was all used. And now it's a right. And there are several rights related to your data in GDPR. And the two most important is that you have the right to know which data is held related to you. And the other one is to know how it's used and for how long, and so all the information regarding the data. These two things can relate to requests that people can do. So as individual, US people included, if it's a EU company, you can basically just send an email or send a form, whatever it is, and you can say, well, hello there, I'm interested to know if you hold any data about me and what you do with it, if you have data. And they basically have to be able to send you your data within a month in a structured format, so like CSV or JSON or whatever. And they need to be able to explain to you how they're using this data and to what purpose. All of this in plain English. So they can't use legal language, they can't use anything like that. And it has to be clear and easy for the people. That has a direct impact on how software is made and how protocols are made and all these things. Because suddenly you can't start creating protocols or software which are very hard to extract this data from. So that needs to be taken into account. So we want to take that into account, and we haven't seen any software done in the recent years which actually take this into account ever. Because through one of the companies that we created, we want or we need to be able to help our clients. That was a need for our own as well. Like, people turn to us and they're like, well, we have this GDPR now. How are we gonna extract the data? How are we gonna know what to do? And how are we gonna reply to these requests? So software and protocols or whatever is created should allow this to happen very easily. So that's like one of the most important things that changed in the last recent years. What we're also going to do is that we're going to separate anything which is identity related from your data. So by identity, we mean your identifiers, your nickname, then your avatar that you may put in any instant messaging platform or whatever. All these things which relate to you, but do not actually, it's not, messages you sent or files you sent or anything like that. We're going to separate them. So we're going to say there's going to be ways you can get identity or you can find people. That's going to be done in one area, which is going to be tightly controlled. And there's going to be ways we're going to do that. And then anything which is the data itself, so messages you send, file you send, anything else, is going to be done another way, because in the end, you don't necessarily need to know who's behind, an ID of a string that appeared in the network, who's behind to read the messages they sent. If somebody doesn't want to say what's their name, if somebody doesn't want to show which server they're coming from in plain text, they don't have to. You may, if you want to know who that person is, you can get in touch with them within the network, and maybe they want to share that data with you. Maybe they don't want to share that with you. Whoever it is, whatever it is, it should be separated. They're two separate concerns. And this very much reflects on the real world. So, when you go buy something at the shop, well, you don't need to say, what's your name? Sure, they're going to see your face. They're going to see how you dressed and all these things, but you don't have to say your name. You don't have to say where you come from. You don't have to say, well, this is my email address. All these things, they're not relevant for some things you want to do, for most things you want to do. And we want to reflect that in the protocol. Next. Yes. Very important, nothing is shared by default. So what we've seen in the protocol so far is that things are shared by default because it's in the interest of the platform to share things. So Facebook, WhatsApp, Telegram, whatever the platform is, the more data they have about you, one way or another, the better, because that's the value. But also, the more people using the network can find out about you, the better. If they can find you easily, things like that, it promotes that platform, even though it doesn't necessarily help the people behind. So we want to have that very big guideline that nothing is shared by default. So you don't share the name, you don't share the profile, you don't share anything unless the person specifically wanted to. So we're not in the business of using people data, and we don't like it as people, as individual, and we're gonna reflect that in what we're creating. So we're gonna put in place in the specification of the protocol, for example, that if you want to be compliant and if you want to be recognized as a grid implementation that is compliant and listed on the website, for example, as one of the top item or whatever, well, you need to respect some of your user privacy and not start sharing things by default. One of the big technical feature in terms of privacy is that everything's going to be IDs, everything's going to be a private key pair. So everything's going to be crypto related. We're going to use ED 25519 and Curve 25519 for those identifier and for the encryption. So your identifier on the network, it's not going to be based on your domain. It's not going to be based on a username. It's not going to be based on anything which could tie it to you. It's just going to be a public key in base64. That's what it's going to be. And then to that, we're going to tie identities, and those identities you're going to be able to share with whoever you want. If you want to share with just your friends, you're going to be able to say, this is the name behind this key. And this also allows that if somebody wants to talk to you and they already know what's your key through the protocol or through discovery mechanism, you can directly encrypt the message, and only the person who's supposed to receive it will be able to receive it and read it. So we should allow encryption and end-to-end encryption to happen by default in a way. So all the other protocol we came across, for example, nobody did that. I just know of Keybase does that, but Keybase doesn't. It's not open source for everything. But everything else, so IRC, XMPP, Matrix, whatever you name it, emails, nobody has IDs. Yes, Tess. I have a question. So are all conversation encrypted by default? Only those where you chose it? Basically, we're gonna reuse the same concept in Matrix as rooms, but we're gonna call them channels. And channels, basically, you can choose what are they supposed to represent. So are they supposed to represent a one-to-one chat, so a direct message chat, or are they supposed to reflect a group chat or whatever? So what we're gonna go for, the specification is gonna say by default the settings should be everything is encrypted. So all the message should be encrypted by default. There might be a reason why in some use case of the protocol this doesn't make sense, because for whatever reason I can't think of one now, but it's very much possible that a client says, oh, we have this specific use, and in that one it doesn't make sense. For example, because it's supposed to represent a public, the equivalent of a public mailing list or whatever. So in those cases, there's going to be a way to flag a channel and say this should not be encrypted by default.
I have a thought. If it comes to sort of defending encryption and strong encryption as part of the app, that may be easier to do if it can't actually be taken out or taken away. That's sort of the WhatsApp and the Signal strategy.
Yeah, I think so. I'm in the strong opinion that at the end of the day, people who implement, so who actually write the software that's going to use the protocol, they should be left to choice. But for sure, we're not going to promote anybody who doesn't go with privacy. It's very much going to be possible to implement this protocol in a way which is not privacy friendly because you put the wrong default settings, or you say that by default nothing is encrypted. If people want to do that, they're free to do that. We're never going to promote that. So this project is not just a technical project for us. Many projects are just technical, or they claim to just be technical and they just want to solve a technical problem. But if you want to do privacy, it's not just a technical problem. It's also a people problem. It's a social problem. And there should be default settings that help things. So what we're going to say is you need to have a very compelling reason to not enable encryption by default. And you should be able to explain it, and it should be like put big red warning in the software when it's the case, and the user should know about it. So if something is not encrypted and you join a conversation that is not encrypted or something, it should be like, you should have big icon, a big message saying this is not encrypted.
So
are you sure you want to join?
Kind of the reverse of the way that it is now in Matrix.
Yes.
Yeah.
So in Matrix, for example, nothing is encrypted by default at this time, and it's not clearly shown either. You have signs that some of the stuff is not encrypted, but there's no big warning about that. What we definitely want to do, and what we think haven't been done maybe the best way, is that it's equally as hard for the developers of those applications that use the protocol to do this encryption by default than it is for user to have it. So it seems like so far the protocol which been designed, they made it really hard for the user and for the developers to have this encryption by default. So I'm not sure how to solve that at this time, or what should be, how it should be reflected. That's what we're gonna learn through the project. But I think it's very important that it should be super easy for developers to create something which is encrypted by default. I don't think the platform so far have managed to do that.
Okay.
So that's, again, it's very much about showing what the social mission and how we want to achieve it. But so what we do is that the IDs themselves are key pairs for encryption, which directly allows to do encryption. You shouldn't have to resolve what's the key for a user and try to find out, talk to the server, or talk to something before being allowed to encrypt and send it. It should be built in, and just if you know the identifier of the entity you want to talk to, you should be able to encrypt directly. And that's why we used IDs as key pairs, so that's possible directly. Self-hosting, it's very broad when we say self-hosting, but self-hosting is super important if you want privacy, because you should be able to know and control who's accessing your data. So let's say that, I don't know, some other user wants to know your display name, wants to know your avatar, or wants to know what's your email through the platform and things like that. You should be able to know when that happened. You should be able to check, if you wanted, when a lookup happened, when when a HTTP endpoint was called, by whom, when, why, things like that. If you use the server of somebody else, if you use the service of somebody else, you're not necessarily able to do that. That's very much reflected recently in things like on Facebook, where people chose, for example, some privacy settings saying, oh no, we don't want things to be seen by anybody by default. And then Facebook whoops in and then says, oh, we're gonna change the settings that they set by default, and we're gonna make them, more open. And people have to go and check themselves if that changed. And also they have no trace that changed, because that's not visible. We really want to avoid that. And what we want to say is, if you use somebody else's computer, you lose some of your privacy. That's how it is. If you don't put your data on your own computer, on the hardware you control, then you lose some privacy. And that means it should be very easy to do self-hosting. So it shouldn't be a burden to do self-hosting. Many of the things we've seen so far, it's very difficult to do self-hosting because you need this big, either the server software is big or it's complicated, or you need to open ports or whatever. So we want to make it in a way that it's very easy to do self-hosting, and that can translate to peer-to-peer communication. That's fine, but we want to very much promote self-hosting. And on the project page and on the repository, that's like the second thing which is listed, is that it's about privacy and self-hosting. So very important for us. And one of the last thing that we've done, and that's more technical, and I'll show that, is that the IDs that you have, if they don't represent a role, so like your email address, just because of the way it's formatted, it's about a user. You have a domain in it which can represent a server, but it's a user by default. And if we want, for example, peer-to-peer to exist by default, well, what is peer-to-peer compared to a federated thing? Is simply a client which is also a server. If you merge a client and a server in terms of feature or in terms of role, well, you do have basically a peer-to-peer network. So what we did is that we ensure the IDs themselves, which allow to identify the entity, are not tied to a role. So that's how we did privacy. The last one, which is user friendliness. What do we need user friendliness? Is that it's easy to use by regular people, obviously. So your grandma, your mom, your dad, anybody who's not technical should not have to struggle to use an app which is created for this, or should not struggle to understand how it works. So if you want to empower the people and explain their privacy, they should rely on things that exist already that understand. People understand email, for example. They understand that if when they send something, well, it's going to be sent to other mailboxes, and we can be on other things. So we should relate to that, and it should be easy in how it is and to understand using simple concepts. And also we should have features, but that's more for the implementation, but it should be supported by the protocol, or the protocol should not block these things from happening. It's features which everybody expects nowadays and should be there. So for example, notifications, push notification on your smartphone or anything. Emojis, very important. People can't seem to live without emojis, and so you have to have them. File sharing, obviously. You want to be able to share your million pictures from your awesome holiday with your friends, or the video of your cat, which you love. One of the things which people seem to want a lot, we love it too. For example, on WhatsApp, is that you can just have voice messages that you can just record and send them out. So we should be able to support things like that too. Same for videos. And finally, one of the things we are very interested in is anything VoIP related. So for example, the very meeting that we're having right now on Zoom, that's one of the things we want to be able to do on Grid. There's no reason, we have to do this on a proprietary platform as well. So for example, and that's one of the first thing we want to work on as soon as we have made more progress in terms of implementation, is to be able to do this kind of thing. So a multi people meeting, voice and audio, with screen recording, with desktop sharing and all these things. So these are the things that we think are very important in terms of user friendliness. And we're going to do that to make sure that people want and like to use the protocol. And that's how we're going to increase the user base. What we've done so far, so there's three things we've done. So the protocol itself, so we started writing the specification of the protocol. For now, it's still work in progress. And it's relying a lot on things that Matrix are doing. So we are a fork of Matrix, so we rely on some of the things we're doing. But we're writing the specification, and I will give you the links at the end. In terms of implementation, we have two implementation. Is the server, we call it GridDepot. And we have the client, which we call Solar. GridDepot is already working in its basic form, so you can already spin a server, you can already connect to other servers, you can join another channel, you can talk to people, you can exchange messages. So not everything works in terms of what you can do, features, but it works, and I'm going to show you in a few minutes how it works. Solar, which is the client, we're still building it, so it's not usable yet, but we'll use something else for the demo. I'm going to show you. And that's it in terms of the presentation of the proposal itself. Is there any questions so far? Or do you want to see things happening?
Let's see it. Let's see it in action.
All right. Okay, so what I did is, you're gonna see code stuff. So basically I have two, I'm gonna spin two server instances locally. One which is called the dark, and one which is called the light. There you go. And I'm going to use a Matrix client to connect to them. So because we're a fork of Matrix, the protocol currently are very, very close to each other. And it's just a matter of translating a simple translation of fields. So we can reuse Matrix client. Wait. So for example, that's one of the server. So, and this is one a Matrix client. But we're gonna use very much, you can see things happening already in the background. And this is all gonna be, the communications are all gonna be grid native. So there's already a protocol behind the scene. Let's create a beautiful user. Let's create a very secure password, 16 characters, randomly generated. I'm gonna register, yes. Okay. So again, you can see stuff happening behind the scene. So I'm gonna just join a room. So this, we're gonna keep the same concept in Grid. We call them channels. So anything, any communication by default happens in a channel. Think of it as an email thread, or think of it as a forum thread, think of it as a group chat, whatever you want it to be. The point is that this is like the basic namespace for the messages to appear in. But it's gonna be, so everything is gonna be a channel. So if you want to talk to somebody, you're basically gonna be able to use, if you want to use a dedicated chat, and there's only one that exists, for example, that's reflected in application recently, like Telegram or WhatsApp or whatever, you can only have one direct chat with somebody. It's always the same. This is possible here too. All you do is that you use the identity as the namespace for the channel, for example. Maybe to show you already. Oh, that's visible. Yes. So here, for example, anything. I'm not sure how much you can see this. Okay. So for example, this is the JSON of a message which is exchanged on Grid. And for example, this is the ID that you have on Grid. This is the ID of my user, for example. So this is a base64 encoded public key, an ED 25519. So it's curve based. Is like a TLS certificate, just another crypto, but it's what it is. And so there's no notion of username in here represented at a protocol level. There's no domain included. There's nothing like that. Everything is this opaque string, which represents a key pair behind the scene. So that's one of the steps we take to ensure privacy. So we don't reveal, your username, or we don't reveal your name directly. You're gonna be able to map something like an email, an address, which is very much like an email. If you want, you're gonna be able to map one to your account, to your identity, and to only give it to the people you want them to use, and you're gonna be able to map as many as you want. But at the protocol level, this doesn't say anything about who's the person behind. That's very important for us. The rest is just technical stuff. So in this case, for example, it says that I joined the channel I just created here. That's the server forum comes from. We're still deciding if we're gonna keep that. The channel on which this happened. So again, just a random ID. The event has an ID itself here, which is even longer. You have the timestamp. Here, previous event, that's what we meant by tag based. So for example, this is the ID of the event which represent the channel creation. So how it happens is that because everything is federated or decentralized, sometimes you do want to allow people to fetch the history of the conversation, and you allow it as part of the rules of the channel you're in. So what we do is we keep track of what has been said, the event ID of what has been sent before. And so with this event, simply I could go back all the way and I could fetch all the previous messages. And the protocol will leave the choice to say this is included or this is not included. It depends what you want to have. And the depth is just a technical field to be able to find out where you are in the conversation for the server. And now, okay. So this is one of the server instances. Now I'm going to go into the other one. And so these are two servers running. They're totally different instances. So one, for example, I can show you the config. One is on port 9009, which is by default, and this one is on 9010. So it's very much two different servers. So I'm going to create on another server. So you can see here, this is the different domain. I'm going to create another user with another super secure password. And so now, for example, I'm going to be able to invite the user I just created. And indeed, I've been invited. And if I do it like this, oops. No, maybe. You can see that I can directly exchange messages. So in terms of server, it works. What you can also do if you want to create things which are called public channels or public rooms is that you can give them an address. So this is something how people are actually gonna find each other, either the address for the rooms or for themselves. So we're gonna give human-friendly identifiers. So as I said before, everything should be user-friendly. So all like the long ID that you have, which is not usable by regular people and they're not gonna understand what the hell is going on, is not gonna work out. What they are used to, on the other hand, are things like email addresses or domains or website addresses. So we should reflect that. And for example, this is, I've just given an alias to this channel and they can join. So think of it as a URL that they can just input and they end up on a page where they can talk. And so I've just added it. And now I can just join from the other server. And obviously it doesn't work for the demo. Oh, I know, wait, my bad. I have to allow it. Okay. And there you go. And so you can just chat. So anybody who has used Matrix so far should recognize what happened here. For those of you who haven't, basically I just showed you how you can have just a chat between two people. And then you can also create channels where you can just join and give out addresses. Yes, Tess, go ahead.
Okay. Let video back in. So the question I'm really curious about, and I think the thing that's the main differentiator for me, both of the grid and of a matrix, is federation. Mm-hmm. And I wanted to hear from you a little bit more about the use case for federation and what makes federation valuable. In particular, I'm curious about whether there are any applications for fault tolerance to make data more secure and make networks more secure in the event of disruption, either due to government censorship or due to attacks, terrorist attacks, natural disasters, or if just why federate rather than using a more centralized protocol?
Sure. Basically, so this, for us, this relates to privacy, but this can very much be applied to what you described. So if you want free communication, or if you want reliable communication, you cannot just rely on the goodwill of one central identity or several central identities to give you a service, which you essentially get for free. You know, when you use WhatsApp, when you use any other things like that, you get a service for free. You don't pay directly. You're gonna pay with your data. You're gonna pay with your usage from what they gather out of it, but you do not pay for it. So it's up to the value of that data and up to the goodwill of those organizations to give you access to messaging. I simply do not believe in a world where you get free things. You have to pay for things that you use one way or another, either your data or not. And if that's the case, you should very much be in control of how you pay that, for that service. So federation and self-hosting are how you control that. So the way I'm currently implementing the protocol, for example, is because everything is a decentralized identifier, it has no way to route the messages. There's no way to know where to send the data just using the identifier. You can actually choose. You're going to be able to say, well, this is the server I want to use, or this is the provider which is going to handle my data, very much like email. So if you change your DNS MX record, you can change who's your provider for your email. That also gives you the ability to basically say, this server is down, please use this other server, because the server you've been using is down. And you're not going to be able to use it because, I don't know, it got destroyed or there was something happened. Up to now, because people relied on DNS, you also have the problem that if DNS goes down, or if you're blacklisted, or if there is oppression, or if you simply are, not likable by the current politics of your country, you could be removed. They could just, delete you from the internet if you have a domain or if you have records. So the way we did it is that we're not gonna rely on DNS for the primary identifier, because it's a key pair, and we're gonna build in the protocol basically messages or headers that you send when you make a request. For example, at HTTP level, there could be a header that says, this is how you reach the identifier. So when you make the request, with identifier ABC, for example, the server you're going to talk to doesn't necessarily know how to reach back to you, or how to verify that the signature you have is valid, or that you empowered to talk for that user, or things like that, or that you're reachable. So because we're going to build a basic routing in the protocol itself, and we're going to say, this is how you can reach this ID, this directly works very nicely for things like what you've described. So if in case of a disaster or whatever, all you have to do, you just have your key pair. So you just have your private key, and you can basically send to the federation or to just servers, and you can just send a message saying, hey, this old server, it's gone, stop using it, start using this server instead. And because we've made it in a way that the ID of a server can be the same as the ID of a user or a client, because it's just a role. It's not built in what they're supposed to be. You can basically say, well, this ID, this public key, is also a server. So you don't rely on anybody to send your messages. You send your messages yourself. Your client application could be sending the messages themselves. And all they say is that they put something at the start of the identifier that says this is acting as a server or this is acting as a user.
So Max, let me stop you for a moment. Are you saying that in some instances you could have better real-time, just-in-time backup and preservation of data through using federation than through a system with data centers and with regular backups? Are you saying it could be an extra layer of protection?
Sure, yes.
Yeah. Say,
I'm not gonna restrict setups like that at the protocol level. So at the protocol level, you're gonna be able to say, these are the endpoints that you can use for this identifier.
say you're a law office and you want all of the data to be encrypted to protect your client's privacy, and you're collaborating with other law offices and you're getting documents from your client and you're storing them on the servers. And say you have 6 or 7 servers running from different points across one continent or across the globe, then if there were disruption in a single area, my understanding is that you would not end up losing data.
Correct. And that's because we've modeled it on real world interaction. So many protocol try to solve the problem of you trying to find the contact point for people you don't necessarily know, or that you have, if there was no interaction before. Which is weird in a sense, because in the real world, when you interact with people, you got to know about them somehow. You don't just look out for somebody you don't know exists in the first place. It usually what happens is you already have people you know, your friends, your family, or things like that, or people like that, or you have a need because, for example, the good example is you need a lawyer and you need to talk to a lawyer, so you're looking out for a lawyer and you look up a lawyer in your area. There is something that bootstrap this communication. There is already something that exists, and we should leverage that. So we're not going to try to solve the problem that many people seem to try to solve, which doesn't necessarily make sense to us, to find people you never interacted with or don't know about in the first place by searching whoever. What we're going to do is we're going to use this communication, which must already exist somehow, to give to give access to. So I don't know if you go to a conference, for example, or here we're having this conversation and this presentation. Well, at the very end, usually what you do is that you give the address or of the project, the URL, or you give a mean to talk to the person, or you use email address or whatever. Those are human-friendly identifiers that you can rely on. Those are the one you want to translate into endpoints and technical information that can be 1 to a million if you want. And it's at that point that you're going to basically say, well, I have 6 servers. Here are the 6 endpoints that you can talk to. Use any of those. And then you're going to also build the connection that says, if you need updates about us, so if you need to know that we've not using this server anymore and we're going to use this other server instead, then that's the point when you're going to subscribe to those updates. And you're going to basically tell the remote server, I'm interested to know about the updates of your configuration. So if you ever change your endpoints, just let me know. And we're going to build that in the protocol. Because here, for example, when you join a room in Matrix, in this case, or you join the channel in Grid, what do? You basically send an event, a message that says, I'm interested in joining. I'm now part of the channel. And the servers are going to send each other update simply because they're in the list of joined members. You can do the exact same thing to know about the updates of a server. You can just join the channel which has the ID of a server, and that's where you get the updates of the server, for example, the public updates. And suddenly you get to know everything about the server that you need to know. And there's no need for special communication. There's no need for some crazy or special interaction, everything is built in the protocol because you have this basic subscription mechanism to anything you're interested in.
So I just texted the chat. To me, that sounds like a self-healing protocol. It's
In a way, yes. Yeah.
As opposed to something which needs a lot of outside tuning and intervention.
Yeah. So many people will rely on things like DNS when they're going to interact with any protocol because it just makes sense. You already have emails, you already have whatever, you already have other protocols that already are based on domains, and you already have your domain, and you already have your email address, and you might want to be found using that email address or things like that. But in essence, we made the protocol in a way that you don't need anything else but the protocol itself. If you want it, you don't need to have a domain. You don't need to pay for domain, which is a centralized system at the end of the day. You don't need to rely on that to interact with the protocol. So if somebody in an oppressive country, or if you're somewhere where you do not have access to domain, you don't have the money, or you don't have the technical mean, or you simply banned because of internal restrictions or whatever, you could still very much use this. Why? Because when you connect it to internet, you do have an IP address at the end of the day. You can still run your own, you can just open a port if you need to, and whichever port it is, and you can just have a web server running, which can be the client itself, to accept incoming connections. Or if you already established a connection within a server, you can just connect to the other server and regularly fetch the messages from them. If you know all the servers that you ever interacted with, if your client keeps the list of all the server, you don't even need to say, this is how you can reach me. All you can say is, you have no way to reach me directly to send me the updates. I will get the data from you from time to time. And that's how you directly build also a peer-to-peer network. Matrix doesn't allow that, for example. It has to be federated. You have to run a server because there's no way to, as a server, to say, give me the recent messages. You're stuck with, having to be able to receive messages.
Cool.
So we very much reusing things that already work from various protocols. So we're using technologies and patterns and way and algorithm that worked already. We know very well because we use them on a daily basis. We basically just spin them a totally different way. We just use them another way than what has been used so far. And that's the difference. So for me, that was very important when we created this project, is that we don't want to reinvent the wheel. We don't want to create a protocol from scratch. We don't want to create interaction from scratch. We don't want to spend years building something totally new, which we're not sure is going to work out. What we've seen is that all the tools and all the technologies were there. Just all the projects so far, each of them individually cared for a very specific need. So some of them only cared for open source, some of them only cared for privacy, some of them only cared for federation, or some of them only cared for user friendliness. So they all have a strength, and we can just reuse what they've done in each area, put it together, and there you go. You get something that can do 4 of them. It's just the way you use it, basically. So we're not going to reinvent something totally new. We just start from something that already exists. And that's why, the server is already running, it's already created, you can already use it, it's very basic. But you can do these things simply because we're reusing something that exists. So we don't have the chance to be able to work on this full time for now, because we have our own clients and other projects we're working on. But for the little amount of time we had so far, we actually been able to make quite some progress, and we're very happy. So the current step is to finish Solr, to make it usable, to at least be able to send a few messages, just in basic interaction with the network, which is using native communication of Grid directly and not using a translation layer for Matrix. And once that's done, basically, we're gonna finish up the specification of the protocol itself. That's gonna be our V, our 0.1 release. We're gonna finish the very basic protocol, and then people can start building on it. And that's just a few weeks away from now. There you go.
We are at about 90 minutes. Do people have questions for Max? Max, do you have more to share?
Unless there are questions, that's what I wanted to show so far. That's it. Unless people have questions.
Let's see, is my mic working?
Yeah.
I guess it's kind of a very broad question, and forgive me if you touched on this. I've been kind of in and out.
Yeah, don't worry. Go for it.
But what's your vision in terms of adoption? Because I feel like since the commercialization of the internet in general, there's really only been one kind of open protocol that's really gotten widespread adoption, and that's RSS. Before any of the standard protocols kind of come from the age before commercialization.
Mm-hmm.
And when working on something like this, to me, half of the vision is, how do we get this to catch on? How do we get people to not want to, to want to use this in lieu of walled gardens and proprietary protocols? And I guess I just like to get your idea or vision about that. The one thing that jumps out at me that maybe kind of fits the answer a little bit is that it's federated, and that I could theoretically throw up a server and then give out accounts to friends and family, just like I can with my email server. But how do we get the world to start using an open protocol again, like this one?
Yes. Two ways I see going about this. So the first one is to see how it was done before and why did it work before. So to me, from what I've seen and from the research I've done, in terms of technical protocols, the others worked because of two things. The first thing was that they actually attempted to create a standard protocol. So they documented a protocol or went through processes like the ETF one, and they made sure that what they were building was created not in the scope of a for-profit or in terms of profit or a startup or anything like that. It was very much an academic exercise of creating a protocol and then saying, I want to get this published and I want this to be recognized as a protocol, not for money, but just because we need it. That was one thing. So that's one important thing, and that's why I directly created a non-profit to back this up. So there is a non-profit that currently exists. That's what I talked about in the very first slide, and all the protocol work. So not the implementation, just the protocol, is run by the non-profit. So the non-profit has full control over the protocol, and ultimately that's what they decide. And I follow like RFCs from ETF. We follow the best practice 9. So it's BCP 9. I'm not sure which RFC it is again, but it's BCP 9. That basically tells you how you can get a protocol through IETF and get it recognized and published, and possibly be adopted as a standard. So we directly follow their process. We don't necessarily show it to the developers, so it's not too complex, but we make sure that in the guidelines we created, this exists. For example, one requirement that they have is that you must be able to show that at least 2 independent implementation have implemented the protocol and it works. So for example, 2 servers that are completely created from independent people, so 2 totally different developers or teams or organization, they just followed the specification, they implemented it, and it worked. And they can talk to each other through their own software. So that's one of the steps, and that's what we definitely want to do. So we're not following in the other things who just create a startup and they create a product. They document what they do, but at the end of the day, they create a product, and they don't really care that it becomes a standard. All they care about is that it does what it does, so they can sell it to the highest bidder 5 years down the line. So we directly stepped away from that, and none of the protocol work is done under a for-profit. Everything is done under a non-profit, to be sure that there's no question about that involved. And the non-profit, the point of the non-profit and the article of association says, we're here to create free software, open source software, and privacy-friendly software or protocol. So that's one of the things, how we do it. And the second one is simply, we should make it as easy as possible for the developers and for the people to use it. So I'm a strong believer in documentation. I'm a strong believer in writing down things and writing guides, how-tos, things like that. I'm gonna spend, I know, a great deal of time writing those things. More certainly, more time on those than I'm gonna write the client server or the specification itself, because you need to have those. All the things I've explained to you, for example, here, what I've presented, people or developers should understand how they work behind the scene, and they should know, how those things are interacting. There are some things I did not talk about that I have, that I plan to do, that can be relied on for both user friendliness and control. For example, friends list or contact list. That's one of the key things we're gonna use to both, allow the user to get in touch with the people they know, but also to give control over their privacy. How those interact, we still have to document, and that's what I need to do. So it's these 2 things. So make sure that it's not a matter of creating something to be sold later on. So it's not a startup initiative. And the second one is just write documentation. A lot of it, which many people don't care about usually in developers. They like to just hack code together, have it work, show it to the world, and be like, oh, look at my cool stuff, but there's no documentation or good documentation that allow you to use it. So that's how we hope to catch on with the people. It's not because it's flashy or anything like that. It's because it has an added value.
Now, to what you were, if I caught one thing that you said in there, since other developers could be left to design different clients, just as we saw in email, we could, they could potentially be relied on to build a better mousetrap, or a more marketable mousetrap. So maybe developers could make their client flashy and kind of attract teenagers, or attract a different demographic with kind of bells and whistles and jangly keys.
Yeah, exactly. I'm not a graphical person. I'm utterly useless when it comes to making something looks nice, or create a graphical interface in the first place. So I'm never going to be the person write the most sexy client that's gonna catch on people. But I will certainly rely on developers or other people that know how to do this. So I will convince them of the added value of this project. And basically, I'm going to tell them, well, look, I'm not able to write a good client or a client that looks good. I'm able to tell you all the other things you need to know and design all the other things. But you're going to have to help us with creating something that looks good. And, that's open source as well, and it's creating this community. So definitely, that's how we're gonna do it. Yes. Well, I'm not gonna try to solve everything by myself. I'm not gonna try to solve every problem by myself, or with Cathy. For now, we're just two of us. I know how to solve the technical problem. I know how to solve the decentralization. I know how to solve the privacy. But that's it. That's what I'm gonna solve first of all. That's what I'm gonna document, and for the rest, hopefully, people will come and help. So, for example, Chad already helped with many things. You did help. You did. So he helped and he contributed things already. He helped us with creating the website, which we still have to finish, but he did a great job. We had loads of discussion about GraphQL. So yes, definitely. And that's how we're going to do it.
Very good.
So Max, can you tell me more about the encryption? So you mentioned using Ratchet. That's what Signal uses too, right? Under the hood is like,
yeah,
it's like an OTP protocol for encryption.
Yes.
So are you planning on like recommending any implementations of Ratchet, or like leaving people up to the wind? Like, is there a library, like a native app library or something, just a standard way of implementing Ratchet and people just like can do it?
I still have to get into the details of that. So for now, honestly, what we're going to do, so in terms, there's several things about the encryption here. So for purely encrypting and signing, this is already all defined. So that's Curve Crypto and it's ED25119. So these already exist. They're already defined. You find information. There's already libraries, many libraries. It's used in SSH, for example. Also, you can use those keys for SSH. You don't necessarily have to use RSA or DSA keys. So this exists. What does not exist, and what Signal use, for example, is the double ratchet implementations of things. So the idea is that it's also forward secure. So whatever you send cannot just be decrypted. Just because you decrypted one message doesn't mean you can decrypt all the others that follow. So that there's already something that exists on Matrix for that. So for now, we're just gonna reuse what they have. What I know is that it's not fully secure. There are some areas which are not secure in those, which need to be improved. I'm not specifically a crypto guy up to now, so I certainly will look for people who understand this more than me or better than me.
And you know that like Matrix's encryption implementation is like such bullshit that like it can't even be like I've wanted to use Matrix's encrypted rooms, but like I join a Matrix encrypted room and there's like fucking 500 devices that I have to approve just for a one-on-one encrypted conversation.
That's nuts. This is the user friendliness part of this. It shouldn't be this complicated. If you want to do crypto, it should be easy enough. Crypto in general, or anything like that, it's not easy. So the way it's designed, at the technical level, you do have to represent these things. The devices and things like that exist, and you have to deal with them. The point is that you should make it easy for the users to deal with this. For me, these things can very easily be solved by simply asking at the very first time you use the client, how do you want to deal with this? Do you want everything encrypted by default, safe? And if it's not possible to do it, just block it, and we don't ask you anything. It's just you want secure and safe. for sure, always. And then all the settings are made, just choose in the list of several options. You just say, I only want secure and safe communication, or I want as safe, as secure as possible, but you shouldn't block communications. Just warn me if something is not right or something is unclear. Or you should have, I just want easy communication, not necessarily encrypted, or I don't care about encryption. Just leave me the fuck alone with that and just let me get on with my communications. For me, this should be like simple 4 options which are presented to the user that they can tweak later. They can go in the settings and they can go into more details if they want to. But for example, Matrix, it's way too complicated from the start. When the first time you turn on encryption and you want to talk to that person, you have that big screen with potentially hundreds of devices that you have no idea what to do with. Like, do I accept or not accept? Do I care? Should I care? Most of the time, you don't even have to care. It doesn't matter. You have no mean to check if those devices are actually real devices that match the user. So this should be made much, much easier. I think this is a matter of asking the user, what's the guideline you want in terms of usage of this? Are you, what profile are you? Are you somebody who's paranoid and really, really, really cares about everything, and by default thinks everything is going to be bad? And all the communication should be made that way, or you just a regular user that has no idea, but also doesn't care and doesn't want to care. There are people that don't want to care about this. They are not interested in encryption, or they do not care about, protecting their privacy. And that's fine. It's not because some people do that you should block others. If you can do full encryption and full privacy, you can do also the opposite, because it's just not turning it on in the first place. So I think it should simply be made easy for the people. There's no reason to bombard them with a million things to check and a million things to validate. It's just give them 4 options at the start, which they can choose later on. You just tell them you can always choose, change this later. You can go into the very fine detail of everything in the settings, but just 4 options, 4 easy options, and that's it. And that's how I want to do everything. It's just make it easy for the people.
Makes sense. Thanks.
Any other question? That's it, Tess, I think.
What's the next milestone?
The next milestone is the full implementation of those decentralized IDs. So all the routing business, all the technical stuff behind the scene that needs to happen, so these decentralized IDs work properly regardless. I'm gonna finish that, which is gonna involve finishing the graphical interface of Solar, the client, and control of those identifiers. And as soon as that's done, we're gonna have the next proof of concept testing, which I'll announce in the channel. And people will be able to join a test channel and test it out with us and see if that works, how we intend it to work. So we know it works with just a few servers. In theory, it works very, very well. Just that obviously once you start having more than 2 or 3 things, you see how things break down and have it do not actually work how you want. So that's the next phase. We're gonna try that. And then we're gonna have a test phase. So a few weeks after, we're gonna have a test phase for more sexy features. So like voice calls and things like that, file sharing, all these things. And then we're basically ready for the first release. That's how it is.
Exciting. Very cool.
There you go. As everybody understood, how this works overall, or not? Is it still foggy on the technical details or what I've explained so far, or is it clear enough? Is more the question. I'm not sure if I went into enough details, or maybe I bored you to death with the technical details, whichever it is. But everybody seems happy about it.
Yeah, I'm impressed with the vision of it, the overall vision of it, and looking forward to it, especially when we reach the point where I can spin up a server.
Yeah, well, you can already spin up a server if you want. Just there's really many people to talk to right now. But you can definitely spin up the server. I will put in the Zoom chat the links to the various projects and the repository so you can see. But basically, you can already spin it up. We use it internally for our own stuff. So we use the server directly. We just don't have the client that goes with it finalized yet. But we use it internally. It works good enough for what we need to do. You don't have all the bells and whistles, but you can already try. And if you want to try directly with me, you just let me know also, and we can, try to connect the servers together and make sure it works. Okay, Chad.
Good to know about.
So that's very important, is that we already have something that works. I think that's maybe it's not necessarily known because I don't specially write it in big letters everywhere that the server is working, because it's still pretty much in testing mode. I don't feel confident yet to send too many people to test it out because it's not user friendly enough to my taste. In this case, for the administrator of the server, they should be able to configure things nicely through a web interface, for example. And they should be able to control and see what's going on, who are the users on the servers, and control the privacy settings and things like that. So once that's done, which is going to be part of the next phases, I will very much promote it. But for now, it's more to whoever is interested can spin it up, as long as they're happy to deal with the technical details of it.
Nice cat, Chad.
It's stealing the show here. What are you doing?
They always do. Gotta get the cats on video.
Yeah. So I will put in the Zoom chat the repository for, so the landing repository for the protocol. The website is not, I'll put the address of the website, but you'll see that it's not fully ready yet. You can still see what Chad has worked on so far. If you want, there's a link to that. Yes, don't be shy. You did a great work. But that's where we'll post the things. But for now, everything very much happens in the repo and in the matrix room that we have for it, which is like the launching room. So as soon as I'm confident enough that the server is stable and I don't have to change the database schema or the protocol too much, because I'm still doing that. So once I'm sure you don't have to delete data or the things you've done in the server, we'll switch to that basically. So as soon as we can, we switch on the network itself, and we're done with other things. So for now, we're still bootstrapping the whole thing.
Okay, great.
There you go. I've put the links. There's in the landing repository, you have the matrix room address that you can join on. There's also the Telegram group for anybody who's using that.
Yeah, I'm on the Telegram group.
In the Telegram, yeah, it's bridged to the matrix room, so you can also we can see what you say there. But there you go. So that's what we're doing. So I think the most important is that we're not reinventing the wheel. We're not trying to rebuild something from scratch and waste years to do something that works. We pretty much just want to use what exists and just make it, privacy friendly. Very much. It's number one goal. We want privacy.
Good deal. I'll have an excerpt from the recording and perhaps the entire recording, we'll see, up on Art Meets Code at some point also.
Sure. Just let me see it first, so I'm sure I'm not
Of
saying too
course.
stupid things. But yes, very happy to have it. And so if you know anybody who would be interested as a developer or as an end user or anything of us, or like graphical people or whatever, just let us know. I'm very much wanting to work with other people, and as I said, I cannot solve everything myself. There are some things I'm just not good at, or I'm only good at certain things. So anybody who could be interested, who could help, feel free to tell them, and we'll be welcome with open arms.
Good to know. Well, thanks everybody.
Thank you for joining. Thank you for listening to me and all the things I had to say.
Well, thanks for putting this together and presenting, Max, despite some last minute chaos. And thank you, Tess, for persevering, and thanks, Michael, for hosting a Receive site. I'm glad this got to still got to occur.
Yeah, me too.
Very happy to hear. Thank you for joining. All right. Well, so Tess will catch up after, and but thank you everybody. So just let me know if there's anything that we can help. I'll give you also my email address if you want to talk to me directly. Feel free to. So whichever medium you want to reach me, us, whoever, it's fine. We are not difficult. We're happy to receive communications in any way you feel comfortable with.
Okay. Well, good night, Max. Get some rest.
Yeah, I'll talk to you later, Les.
Thanks for
Thank you, everybody.
But, this is fun.
Bye-bye. Take care.